June 28, 1942, 11:47 a.m. The salt-stained beaches near Calais, France. Hauptmann Werner Schreuer watched through his binoculars as smoke traced a dark line across the Channel sky. Another British fighter going down. The Luftwaffe pilot allowed himself a tight smile until he saw where it was landing. Not crashing, landing. The Spitfire's wheels touched French soil with barely a bounce. The engine coughed once, then died. In the cockpit, a young RAF pilot sat motionless, hands still gripping the controls, realizing he'd just delivered Britain's most sophisticated fighter directly into enemy hands. Within hours, Wehrmacht engineers surrounded the aircraft like surgeons around an unexpectedly healthy patient. The Spitfire Mark VB, serial number AB910, sat intact on German soil. No bullet damage to critical systems, no fire, no structural compromise. Oberst Friedrich Lang, head of the Luftwaffe's Technical Intelligence Division, received the call at Rechlin test facility that evening. His response was immediate. "Do not touch anything. I'm sending our best team." What the Germans discovered in the months that followed would shatter every assumption they'd made about British engineering and force them to completely rewrite their fighter tactics manual. The Messerschmitt Bf-109 had dominated European skies since 1939. German test pilots knew every centimeter of its performance envelope. They'd studied intelligence reports on the Spitfire for years, grainy photographs, pilot interrogations, debris analysis from downed aircraft. The assessment was clear. The Spitfire was a competent defensive fighter, built for tight turns over Britain, but fundamentally limited. Intelligence estimates placed its weight at approximately 3,200 kilograms fully loaded. German engineers calculated its sacrifice speed and climb rate for maneuverability. A defensive weapon. Nothing that should concern a properly trained Bf-109 pilot in offensive operations. Hauptmann Ralph Pingle, the Luftwaffe's chief test pilot at Rechlin, had reviewed these reports dozens of times. He'd flown against Spitfires in combat over the Channel. He knew their patterns, their limitations, their predictable defensive tactics. When he received orders to conduct comprehensive testing on the captured aircraft, he expected confirmation, not revelation. He was about to be proven catastrophically wrong. July 15, 1942. Rechlin, a Probangstelle test facility, northern Germany. The first test wasn't even a flight. German engineers placed AB910 on precision scales, expecting to confirm their 3,200 kilogram estimate. The instrument settled at 2,911 kilograms. Pingle stared at the reading, then ordered his team to recalibrate. They did. The number didn't change. 2,911 kilograms. The Spitfire was nearly 300 kilograms lighter than German intelligence had calculated. In aviation engineering, 300 kilograms isn't a rounding error. It's the difference between adequate and exceptional, between defensive and dominant. Everything about the performance envelope would have to be recalculated. The power-to-weight ratio alone suggested climb rates and acceleration figures that seemed impossible for the Merlin engine's known output. "How did they do this?" Pingle's engineering officer asked, examining the aluminum monocoque construction, the elegant load-bearing skin, the absence of redundant structural elements. Pingle didn't answer. He was already strapping into the cockpit for the first flight test. July 23, 1942. First comparative flight test. The test protocol was straightforward. Pingle would fly AB910 against a Bf-109F, the Luftwaffe's latest production model, in mock combat scenarios. A second German pilot would attempt to stay on the Spitfire's tail through standard engagement maneuvers. At 4,000 meters altitude, Pingle pushed the Spitfire into a maximum performance turn. The Bf-109F tried to follow. It couldn't. The Spitfire's turn radius was so tight that the Messerschmitt pilot found himself overshooting repeatedly, unable to keep the British fighter in his gun sight. Pingle completed 3 full circles before the Bf-109 managed 2. On the ground, Luftwaffe observers tracked the engagement through theodolites and timing equipment. The measurements were unambiguous. The Spitfire could complete a 360-degree turn in approximately 16 seconds at combat speed. The Bf-109F required 21 seconds for the same maneuver. 5 seconds. In aerial combat, 5 seconds is the difference between the hunter and the hunted. But it wasn't just the turn radius, it was the controllability throughout the turn. Bf-109 pilots knew that pushing their fighter to maximum turn rate meant fighting heavy controls, inducing buffet, and risking departure from controlled flight. Pingle reported that the Spitfire remained light and responsive throughout the entire performance envelope. The controls gave constant feedback but never became heavy. The aircraft wanted to turn. "It's like comparing a truck to a sports car," Pingle wrote in his initial assessment. "Our intelligence estimates weren't just wrong, they were dangerously, completely wrong." August 1942. Extended Flight Testing Program. German fighter tactics relied heavily on the Bf-109's superior roll rate, the ability to snap from one bank angle to another faster than enemy aircraft. This allowed Messerschmitt pilots to reverse direction quickly, evade pursuit, and control engagement geometry. The captured Spitfire demolished this assumption. In direct comparison tests, the Spitfire's roll rate equaled or exceeded the Bf-109F at most speeds. The British fighter could transition from full left bank to full right bank in under 2 seconds at combat velocities. More disturbing, the Spitfire's ailerons remained effective at high speeds, where the Bf-109's controls stiffened significantly. Above 600 kilometers per hour, the Messerschmitt required substantial pilot strength to execute rolling maneuvers. The Spitfire's controls stayed light and responsive. Oberst Lang reviewed the test data with growing concern. German tactical doctrine assumed Bf-109 pilots could always roll away from pursuing Spitfires. The captured aircraft proved this was suicidal advice. Any pilot who attempts a rolling escape against a competent Spitfire pilot will find himself in the enemy's gun sight within seconds, Lang wrote in his report to Luftwaffe High Command. "We have been sending our pilots into combat with fundamentally flawed tactical guidance." September 1942. Vertical performance testing. The test was simple. Both aircraft would climb from sea level to 6,000 meters at maximum sustainable power. The Bf-109F would establish the baseline. The Spitfire would attempt to match it. The Spitfire didn't match it. The Spitfire exceeded it. At lower altitudes, the two fighters climbed at roughly equivalent rates, but above 3,000 meters, the Spitfire began pulling away. Its lighter weight and the Merlin engine's supercharger characteristics gave it a measurable advantage in the critical combat altitudes where most engagements occurred. By 6,000 meters, the Spitfire had arrived 40 seconds before the Bf-109F. 40 seconds of altitude advantage, 40 seconds to position for attack, 40 seconds to claim the vertical initiative. Pingle's report contained a single, devastating sentence. In combat conditions, the Spitfire pilot can choose whether to engage or disengage at will. The Bf-109 pilot cannot prevent either decision. This was the nightmare scenario for German Fighter Command. The Spitfire wasn't just competitive, it held the initiative in three-dimensional combat geometry. October 1942 to March 1943, Rechlin Facility. AB910 became the Luftwaffe's most valuable training asset. Every available fighter pilot was rotated through Rechlin for familiarization flights against the captured Spitfire. The exercise was humbling. Experienced aces, men with dozens of kills, found themselves repeatedly outmaneuvered by the British fighter. The Spitfire's combination of turn performance, roll authority, and climb capability created engagement scenarios where German pilots had no advantageous options. New tactical guidance emerged from these training sessions. Never attempt sustained turning combat with a Spitfire. Do not rely on rolling maneuvers for escape. Avoid climbing contests below 6,000 meters. Use the Bf-109's slightly higher top speed to dictate engagement range. Attack from superior altitude whenever possible. Disengage vertically if the tactical situation deteriorates. It was a defensive doctrine, built around avoiding the Spitfire's strengths rather than exploiting its weaknesses. "We are teaching our pilots to survive," one instructor noted grimly, "not to dominate." Winter, 1942-1943. Technical analysis reports. German engineers spent months dismantling, measuring, and analyzing every component of AB910. Their findings read like a confession of engineering philosophy. The Spitfire was designed from the perspective of what the pilot needed, not what the engineering department could easily manufacture. Every structural element served the pilot's tactical requirements. Nothing was included that didn't contribute to combat effectiveness. The elliptical wing, initially dismissed by German analysts as aesthetically pleasing but structurally inefficient, proved to be a masterpiece of aerodynamic optimization. It provided maximum lift with minimum induced drag, while maintaining benign stall characteristics. The control system used thin cables and pulleys, where the Bf-109 used heavy push rods and bearings. Lighter, simpler, more responsive. The fuel system prioritized pilot survivability with self-sealing tanks and redundant feed lines. German fighters had only recently begun incorporating similar features. "They built an aircraft for combat," one engineering officer wrote. "We built an aircraft for production efficiency and assumed it would be adequate for combat. The British approach is superior." April 17, 1943, 2:31 a.m. RAF bombing raid on Rechlin facility. The air raid sirens wailed across the test base. British bombers, likely acting on intelligence about captured facility, methodically destroyed hangars and workshops. AB910 sat in Hangar 7 when the incendiary bombs fell. The Spitfire that had taught the Luftwaffe humility burned in the same type of fire that had consumed so many of its squadron mates over occupied Europe. German firefighters watched the aluminum skin curl and blacken, the elegant wings collapse, the fuselage buckle in the intense heat. By dawn, only the engine block remained identifiable. But the knowledge AB910 had provided survived in hundreds of tactical reports, training documents, and engineering analyses. Every Luftwaffe fighter pilot trained after October 1942 learned to respect the Spitfire's capabilities. Lessons written in the test data from a single captured aircraft. The Focke-Wulf FW-190, introduced in 1941, incorporated many design philosophies that German engineers had observed in the captured Spitfire. Lighter control systems, improved roll rates, better high-speed handling characteristics. Whether these features were directly inspired by AB910's analysis or parallel development remains debated by aviation historians. What isn't debated? After October 1942, Luftwaffe tactical doctrine treated the Spitfire as a peer adversary, not a defensive nuisance. Loss rates among German fighters improved marginally over the Channel and Northern Europe. Pilots who'd trained against AB910 had measurably better survival rates than those who hadn't. Pilot Officer Burling Smith, the young RAF officer who'd made that forced landing near Calais, spent the remainder of the war in a German POW camp. He never knew that his captured aircraft had granted the Germans their most valuable intelligence windfall of the air war, or that it hadn't helped them nearly enough. By war's end, Spitfires had destroyed an estimated 1,200 Luftwaffe aircraft in aerial combat. The lessons from AB910 taught German pilots to survive encounters with the legendary British fighter. They never taught them how to win. The museum at the Royal Air Force Museum Hendon displays Spitfire Mark VB serial AB910's recovered data plate, retrieved from Rechlin facility after Germany's surrender. It sits in a modest case near the main Spitfire exhibition, a small piece of aluminum that represents the moment Germany's finest test pilot strapped into an enemy fighter and discovered that everything he'd been told was catastrophically wrong. Some victories aren't won with bullets. Some victories are won by building an aircraft so fundamentally superior that even your enemy's best pilots can't deny its excellence.